Okay. All right. Hopefully we can hear each other. Hello! Okay. So we have this, we have that, we have this. Hello. Okay. So what we're going to do is we're going to be going live. Okay. What are we doing? We're sharing everywhere. So we do 1, 2, 3, 4. So we have 4 on the abacus. And then what we're going to do is we're going to do 5. To do 5 on the abacus is always going to be the top beat. Welcome. Thank you. Hey, Ethan. Good evening. Good evening, Ethan. How are you doing? Thank you so much for the like. Yeah. So what we're going to do is we're going to do 6. So on the abacus, we're going to do 6. This is what 6 is because we have 1 beat on top and 1 beat on bottom. So if I did this, we have 2. We know this is 2. Oh yeah, this is it. So if this is 2, right, and I want to add the 5, I'm going to add the 5. Ooh, I'm going to add the 5, right? Now we have 7. So let's what happens. What happens when we do 3? We have 1, 2, 3, and then I add the 5. We have 8. So notice when I add the 5, this is always going to be the 5. The top beat will always be 5. Thank you so much for the likes, Ethan. Welcome, everybody. Welcome. Good morning, good morning, good morning. So if I have 4, we've done this before, right? 1, 2, 3, 4. Because we have 4 and then I add the 5, we have 9. So after 9, we have 10. We've seen this before because we did this, right? So we have 1 and then this is 1. This is actually 10. If we look at the abacus, this is how we write 10. So notice we have our 1 and our 0. This is what we call, we can use like 0 and 1 over here. And then we have 11. After 11, we have 12. This is what 12 looks like, right? So 12 looks like 2, 1, and a 2. Let me know if anybody has any questions. Good morning, good morning, good morning, good morning. So what we're doing is we're reading how to read the abacus. When we learn how to read the abacus, then we're going to have to learn, then we will learn how to add, subtract, multiply, and divide. It depends on how far we can get with multiplication and division. All right, so the first thing we're going to do is understand how to read the abacus, and this is 0. So this is 0 when none of the beads are touching the horizontal bar. The horizontal bar is what's counted. That's what's being counted. As we count the horizontal bar, we move the beads, they go up. That is counted as 1. And then we have 2. This is counted as 2. And then we have 3. That's 3. 1, 2, 3. That's easy to see, right? And then this is 4. This is also easy to see. So, well, what happens after 4? Well, notice 5 will be the top bead. 5 will always be the top bead. So I'll show you in the different scenarios how 5 works. When we look at it, we have 1, right? We did 1. We understand what 1 looks like. But then when we add 5, right? When we add 5, which is always going to be the top bead, now we have 6. We have 2. And then when we add 5, we have 7. Notice that the top bead is adding 5. So we have 5. So we have 2, and then we have 5. We have 2, and then 5. Oh, no, sorry. 2, and then 7. 2, and then 7. I'm not used to this way of teaching, but I'm going to try this way of teaching. It'll be interesting. So what we're doing is we're counting on the abacus. We have 3. Okay, we have 3, but then when we add the 5, this is now 8. The top bead always has a value of 8. The top bead always has a value of 5. Sorry, it's a little early right now. So we have 5. This is 8. 5, 6, 7, 8. So we have 4. If this is 4, and notice if I add the 5, now we're at 9. So that's why they're very similar. I don't know if we can do it that way. Oh, maybe I should do that. Maybe I should do that. So they're very similar if you think about it. So we have 4, again, just to show you, I have 4. This is what 4 looks like. And then if I add the 5, I'm going to add the 5. Now I have 9. Let me know if anybody has any questions, and I will continue on teaching how to read the abacus. Once we learn how to read the abacus, we will be able to do some adding, subtracting, multiplication, and division, but it depends on how far we get. So the first thing we're going to do is understand that this is 4. When we have 4, but notice this is not just 4. Now we're going to talk about place value. If I line this up, now I have 4,000. So we have ones, tens, hundred, thousands, 10,000. When we look, we have 4,000. Now, if I add the 5, we have 9,000. Does that make sense? Let me know in the comments if this makes sense to you. Good morning, everybody. Good morning. Good morning. Hello. And if anybody has any questions, let me know. So what we're going to do is we're going to do ones, tens, hundreds, thousands, and 10,000. So when we count it, oh, hey, thank you, Lou. Wait, can you do that again now? Oh, hey, Noelle. So we do 1, right? So when I look at it, this is what we're going to be talking about. Thank you so much for the comment. Yeah, probably AFK. So what we're doing, this is the 0, right? Why is this 0? Because none of the beads are touching the horizontal bar. When the beads are touching the horizontal bar, then they're being counted. So this is 1. That's 1. That's easy, right? But then when we add this thing with the top bead, this is 5. So if we look, this is 5. This is minus 5. This is plus 5. We're adding the 5. We add the 5 to the top bar. But now if I add 5 to 1 is now equals to 6. So when we look, we have 2, right? Easy. 2, not a problem. But then when we add the 5, we have 7. What happens when we do 3? Right? We have 1, 2, 3, easy to see, but we add the 5, we're now 8. And then we do it again. If we have 4, oh, now there we go. If we have 4, and then we add the 5, there we have 9. Now, what happens if we had 1? Or I'm sorry, what's after 9? After 9 is 10. Notice we've seen this before. So now it's a pattern. So we have a 1 or 1. But if we put it in a place value, we have 10. So if you kind of think about it, 0 is the placeholder. So we have a 0 and a 1. So then we have 11. That would be 11. 11 just looks like 1 and 1, just as how we write. So abacus, oh good love. Abacus mimics the way we write. So when we write, we have 11, 1 and 1. And it concludes the sentence. Very good. That's so good. Not too many people actually made that connection, but you're absolutely right. So when we look at it, we have 12. This is 12. 1, 2. And then what Love was talking about is the decimals. So when we look at it, we have our ones, our tenths. The decimal sits in between the ones and the tenths, just as the decimal sits between the ones and the tenths. The decimal does not sit on a place value. So when she was talking about, it is 15. So we have 1 and a 5. So we have 12.15. And that's how we read the abacus. Thank you for the follow. Does that make sense, Noelle? Yeah. And then probably AFK. There we go. Hello. Good morning. Good morning. Good morning. So when we read it, right, we have 1, 2, 3, 4, and then 5, 6, 7, 8, 9. So the way I did it before was 1 and then 6. Why? Because we're adding the 5. When we add the 5, we add more. So we have 5. We have 5 and then we have 6. 1 and 5 is 6. So if I had 2 and I add the 5 is now 7. Well, I've been here for... Yeah, thank you, Energizer, that DJs. Keep it saying some people. You keep saying some people might be AFK. It's because there's a person. Their screen name is AFK. So 5, 6, 7, right? So we have 3. When we have 3 and we add the 5, now we have 8. If I have 4 and I add the 5, we have 9. Now, if you look, we have AFK means like currently not here. Yeah, I understand, Noelle. Thank you so much. But there's also a person's name, probably AFK. So this is 10. How is this 10? Because we have 1 and we have 1. 1 in the tens place and 1 in the ones place. So when we look at it, we have 1, 10, 100, 1,000, and 10,000. Whoa. So when we are looking, all of this, if we're touching this, if we have all of the beats touching the horizontal bar, now this is called 9. 9. This is all 9. So we do 9, 9, 9, 9, 9, 9, 9. So that, excuse me, that when we write it out looks like this: 9, 9, comma 9, 9, 9.99. So that's what this looks like. So every bead, every column is being counted. We have our ones, our tens, our hundreds, our thousands, our 10,000s, and then we have our tenths, and then we have our hundredths. So this is what we're doing is on the abacus, we also provide a place value. It's easy to read. So even when I do this, right, even if I did this, I know this is 500. I know this is 500 because why? This is my ones. If you notice, I have a dot indicator. This is my ones indicator. This ones indicator tells me that this is the ones, tens, hundreds, thousands, 10,000. You could use this one if you like choosing a Pokemon. You could choose this one. I choose you. You could, but then you wouldn't have hundreds. You would have a lot of decimals, but you wouldn't have a lot of hundreds. So it'd be the ones and the tens. So that's why I choose this one to be my ones, so then I can have more numbers. So when we look at it, we have our ones, tens, hundred, thousands, 10,000. And if you see, they're being grouped. So now I know that from here to here is 1,000. And then if I had a bigger abacus, like this one, this is a 13 column abacus because size matters. This is my 13 column abacus, I can actually have more numbers. If I choose to be in the middle, then I have all of these numbers to be, or I have all these decimals. Or if I decide to choose this one over here, then I have ones, thousands, millions, billions, and trillions. When we look at it, we have 13 digits. That's why there's 13 columns. And if you want to track the national debt, you would have to get a bigger abacus, which is 23. I have a 23 column one. This is 23 columns, and it works exactly the same. It works exactly the same. It has nothing to do with the colors. So what's going to happen is I'm going to use this, which is over here. If you notice, again, I have two columns for the decimal for my cents. So I have my ones, my thousands, my millions, my billions, my trillions, quadrillions, and then quintillions, I think. I don't know. I don't know what's after this. I've stopped researching after that. But you can track the numbers, and it's 23 columns. Now, if you notice, this one is made out of bamboo. This one's made out of bamboo, but I've had this for a long time. And then these are all made out of plastic, and these are kind of more recent. Anybody have any questions? Let me know. If anybody have any questions, let me know. So we learned how to read the abacus, and what we're going to do is we are going to do some bead recognition. We're going to do some number recognition. We're going to do a maze. Are we ready for a maze? What's a maze? Well, a maze is, let's see. Oh, you know what? We'll do this. So what we're going to do is we're going to do this maze. And what it is we're going to track the numbers, and as we track the numbers, we will follow a maze. So that's what this is. This is my maze, and this is what I have. And what are we going to do? Well, what we're going to do is we're going to follow the path to find. So we start from here, and we keep going until we get to the finish line. So if you guys are ready, we are going to start. So the first thing we're going to do. Maybe that's better. Oh yeah, there we go. First thing we're going to do is understand, what number do you think this is? There we go, there we go, there we go, there we go. So we have this number, and that. What number do you think? Oh, that's pretty quick. Thank you, Energizer DJ. Okay, so that is 61. You're absolutely right. Oh man, all these years I would have never guessed I would learn the abacus. Yeah! I've been teaching abacus for 20 plus years now, so welcome to the real world. So we have this number, right? We have this, and then we have that. What number do you think this is? So right now what we're doing is we're learning how to read the abacus. The reason why is because after we learn how to read the abacus, then we can actually go into adding, subtracting, multiplication, and division. Good job! Good job, Energizer. So yes, you're absolutely right. So if I did this, 1, 2, 3, and then 5, 6, 7, 8, 9. So then when we look, our number is 39. So then our final, then our next answer is this. If I have that, what are we doing? Anybody have any questions? Let me know. So we have this number, and then we have this number. What number do you think that is? There we go. 51. Yes, 51. Because there's a 5 up here, and then there's 1 here. Noel, hey, good. Thank you, love. Awesome. Right? So this is my little maze, just to do some practicing practicing how we read the abacus. So that's what we're doing, is we're learning how to read the abacus. When we do it, right? So we have this one, and then that. What number do we know that is? Ah, good, love, good, love. 64. We have 64. So we have 5, 6, and then 4. 1, 2, 3, 4. Okay, so that's 64. Okay, so then we have this number. Don't forget that this is my tens, and so I'll be up with the ones. So if this is my ones, hey, cactus fruit, welcome. How do we know which number to start with? Usually I start with where the dot indicator is, right? So my dot indicator, this is my ones indicator. Thank you for the number 3. Yes, 1, 2, 3. So we're going to go here, and we do this. So this one's going to be easy because we know that one. I've showed you that one. So Jackie, when we look at it, we have our numbers. This is our ones and this is our tens. And the top bead will always be 5. Wow, I came here late and I'm definitely lost. Oh, Mads, that's all right, because we're going to review. So thank you, 99. Yes, thank you, Energizer. How about you, love? You all right? So, Mads, what we're doing is we're reading the abacus. And to read the abacus, we're going to understand how to count it. So we do 1, 2, 3, 4, and then 5. All the top bead has a value of 5, 6, 7, 8, 9. Ooh, PB Bunny. Energizer, I love Atticus. Welcome, Atticus. Love 91. Yes, that's exactly right. It is 91. How do I know? Because we have 5, 6, 7, 8, 9, and then there's 1. So you're absolutely right. 5, 6, 7, 8, 9, and then 1. So when I look, I'm going to go over here. My next number is this. What is my next number? So if I look, I have this, and then I have that. Mads, does that make sense? Ah, thank you. So if you touch the divider, including, if it is touch the divider, we include, yes, you're absolutely right. Geek proud, oh wow. Yes, Grace, almost, 75. How do I know? We have 5, 6, 7, and then 5. So this is 5. The reason why is this is the horizontal bar, and anytime that the beads are touching the horizontal bar, this is being counted. So we have 5, 6, 7, and we have 5, right? Does that make sense? Yes. 75. So we're looking at 75. Ooh, it's over here. 75. So when we look at it, we can see. Now I'm using this indicator. This is my dot indicator. This is my ones indicator. Do you see that dot there? So this is my ones indicator. And when I look, I do my 5 and I have my number 1, 2, 3, 4. When I look at it, right? Thank you, 54. Exactly. When I look at it, this is my place value. So every column is a place value. Thank you, Cactus and Grace. And hey, Miru, welcome back. Made by Mullis. Sorry, I don't know why I stepped on that. So yes, so we have 5 and then 4. 1, 2, 3, 4. So my answer is 54. So now my next question is, what number is this? So if I look, this is my tens, and then this is my ones. So I add this. So when I look at it, what number? Oh, you guys are fast, geek and proud. Yeah, Nima, made by Melise and Miru. Yes, 25. It is 25. How do I know? Because it's 2, right? 2, and then the 5. And we bring it together, and then we get 25. And so we're almost done with our maze. Yeah, this is cool. Thank you guys for participating. So we have this number, right? We have 5. So we have 5. And then we have 5, 6, 7, 8. Yes. Thank you guys. Thank you, Cactus and Geek and Mina. Okay. Thank you, Miru. Okay. And then this is 7, 8. No, I'm sorry. 5, 6, 7, 8. That's 8. And our final answer is, survey says, where are we? Where are we? This is my maze. This is the maze. We just followed a maze, and I was just following through. So what number is this? 42. Yes, right? 42, because it is the answer to the universe. If anybody if anybody has read, if anybody's read the Hitchhiker's Guide to the Galaxy, they know that the answer to the universe is 42. You got it. Awesome. So now we know how to read the abacus. So this is a little bit of an activity to understand how to read the abacus. And then, obviously, if there is 2-digit, there will be 3-digit. We don't need to do 3-digit, but that's just to show you, right? So if anybody's interested in this one, I am selling it on my website. The link's in the bio. But I do have a 2-digit one, and I have a 3-digit one. Am I a math teacher? I am a math teacher. I'm teaching math right now, Mads. I am going to call myself a math teacher, even though even though this is a forgotten tool. This is a forgotten math tool. I don't know why people know like everything else except for this. More people need to learn this. Yes, you're absolutely right, love. And that's what I'm trying to do. I'm trying to educate the world about the lost tool of the abacus. All right. Anybody have any questions? Because after this, I'm going to start going into adding and subtracting. So adding, oh, thank you so much for the heart me. Okay, anybody have any questions other than am I a math teacher? Because I believe I am a math teacher, even though I use an abacus. All right. So the reason why I want to talk to the world about the abacus, because I think it's the greatest thing next to sliced bread, and I believe it's a forgotten tool. Don't be sorry, Mads. I think it's completely funny. I think it's hilarious. I am not offended if you think I am. I'm not offended. This is funny. Okay, so the first thing we're going to do is we're going to understand how to add and subtract, right? So the first thing we're going to do, the first thing we did was we understood how to read the abacus, right? That's the first hurdle. The next thing is just to start moving the abacus. And what does that mean? Well, we've done all of this. We know what numbers are greater than, what numbers are less than, right? But this is a book for preschoolers. But what we're going to do is understand that we're going to focus on the add-in. The add-in is what we need to do. Why? Because in school, we were always teaching the kids, let's make a 9. How do you make a 9? A 9 is a 1 and an 8. It's like, no. In abacus, we don't focus on the result. What we focus on is the add-in. What does that mean? Well, we focus on the number that we're adding to, right? It's about the process. You marry the process and you divorce the result. So the thing is what we do is we need to change a little bit. The reason why I stress this is because in school I was talking to a teacher friend, and he was like talking about trying to introduce abacus to school, to his class. He's a second grader, and the problem is he needs to change his mind from saying let's make a 6 as opposed to how do we make a 6. Would you recommend getting practice books? You could get practice books, depending on how old you are. I have this one, which is a preschool one. I do have some other ones in my site. Where? There's that one place. There's one in my bio, right? I do sell this one in my bio. I do sell on Teachers Pay Teachers, and this is my store name. And then I do sell on this one, and this is my name. Hi, everybody. I try to be available, with digital downloads and then a link in my bio. But if you don't trust me, that's fine. I have a TPT store. Yep. Yeah. Let me know if you have any other questions. Oh yeah. So there's that. So to buy the 13 column one, you can get it at Daiso. If you're looking at this one, I sell it on my website. Oh, thank you so much for the share. So I sell this one on my website. You can get this one on Daiso, or I'm sure there's whatever. And then and you might be wondering, does it matter? It doesn't matter which one. It really doesn't matter because they're all manufactured the same. If you get a little bit bougie, if you get a little bit more expensive, this one's a little bit more expensive because it's made out of bamboo, and this one's made from Japan, like the actual company called Tomo Soroban. But this is an old one. I've had this one for about more than 20 years. So, anyways, so what we're gonna do is we're gonna understand how to move the beats. Good morning, Hep. Welcome, Hep. All right. So what we're going to do is we're going to learn how to move the beats. When we learn how to move the beats, what we're going to do is this is 5. We know that this is 5. When we put it on the abacus, you're going to start seeing the numbers. This is why we need to learn how to read the numbers. It's the queen. Thank you. Welcome. So we have 1, and then what we're going to do, I'm sorry, we're going to have 5. This is the 5. And then we're going to add the 1. We add 1. When we add 1, right, this is the add-in. Our final answer is 6. So notice what I'm doing is I'm moving the beads. It doesn't matter if it's this bead or this bead. The idea is to know that I'm only moving the one bead. We're only moving the one object. So when we're doing it, we have 1. And then this is 1. So if this is 6, if we had 6, and then we add the 1, that's what we're doing. Add 1, then my answer is 7. 5, 6, 7. And then we add another 1. If we add another 1, right, from 7, and then we add 1, this is 8. So it's kind of like counting, right? But the idea is to know that we're adding one bead. After we add the one bead, we know we're going to add 2 beads. When we add 2 beads, right, we go to the horizontal bar. If you want to subtract, you go away from the horizontal bar. So this is the horizontal bar that we're talking about, right? This is the horizontal bar we're talking about, and this is what tracks our counted numbers. When we count our numbers, we go to. We're adding. We go to the horizontal bar. When we're subtracting, we go away from the horizontal bar. So again, this is 7. So it's 7 plus 9. I'm sorry, 7 plus 2 is 9. Make sense? Let me know if you have any questions. So this one specifically has a little bit more activities because I wanted to get them more engaged. So you answer the question here and then you find the answer on the puzzle piece. And then we have 3. When we add 3, it's the same thing. I add 5, I go to the horizontal bar. And I want to do is I want to add 3. When I add 3, hello, Jose. When I add 3, it's to the horizontal bar. So I'm going up. And then my final answer is 8. Anybody have any questions? Make sense? Does this make sense? So 4 doesn't have a lot of questions because it's only 4. Right? 4 doesn't have a lot of questions because it's either 0 plus 4 and I add the 4, or it's 5 plus 4 and I just add the 4. Then obviously we've done the minus, right? I've told you how to do the minus. Minus is taking away. So if I had 4 and I want to take away 1, I'm just moving it away from the horizontal bar. So if I'm going to add the 1 or I take away the 1, it's the same thing. If I want to take away the 2 or I'm going to add the 2, take away the 2. It's away from the horizontal bar. So that's what we're doing here. But wait, we've only done 4. Yeah, that's the way I wanted to keep within the structure of the abacus. So we just did adding the 4 and we did the takeaway of the 4. Now what we do is after that we do adding of the 5. Adding of the 5 is the same thing. We add the 5, we go to the horizontal bar, we take away, it's away from the horizontal bar. When we do 6, you bring together at the same time. This is to the horizontal bar. When it's away, you take it away, right? This is just showing you how to move the beads. So if I had 1 and I want to go and want to add 6, I'm taking one bead on top and one bead on the bottom and adding it, right? So that's what I'm doing. I'm doing it together. When I take away, I push it away from the horizontal bar. Does it make sense? Hey, Miru, thank you. Welcome, welcome. So, anybody have any questions? So we did 6, and then let's do 8. So if we do 8, thank you for the share, everybody. Thank you so much for the share. We do 8, we have 1, and plus the 8. 5, 6, 7, 8. And we bring it together. And then my answer is 9. All right. Are we done? Are we done? We're not done. You know why? Because there's more to it. What happens when there's not enough beads? So if I want to do 3 and I want to add 4, what do? I don't have enough beads. Do you see that I don't have enough beads? I don't have enough beads to add 4. So what is my question? Here's my question. Nope, that's not my question. There it is. There it is. So if I add 3, my question is I want to add 3. So I have 3 on my abacus, but I don't have enough beads to add the 4. Move the next one over. If I move the next one over, then I get 13. If I do a next one over, this would be 33. So we still follow the restrictions of our numbers, right? So it is not, what we're going to do is we're going to utilize the 5. What does that mean? Well, in school, I don't know if you remember, in school, we're going to learn, yes, that's what we're going to do. Yes, thank you. In school, we're learning how to do this. Add the 4. 1 plus 4 is equal to 5, and 1 plus 5 is equal to 4. Exactly. So what we're doing is we're going to utilize the top bead. When we utilize the top bead, we don't want to have any freeloading numbers. How did we get that? Well, the first thing we're going to do is we're going to understand that the question is 1 plus 5. We know this concept. If we know this concept, thank you, Geek and Proud, and Melissa, yes. So notice what we're going to do is we're going to isolate this variable because this 4 is this same 4. And then what's going to happen is I move the one bead over. I'm going to do 4 is equal to 5 minus 1. You've guys taken this before. So what I'm going to do is I'm going to add the 5, and now these are directions. I'm going to add the 5, and I'm going to take away the 1. So my final answer is 7. Now this works very well, and it becomes more versatile. Why? Because when I want to add the 4, it's the same thing. If I add the 4 and I want to add the 5, all I have to do is plus the 5, take away the 1. Does that make sense? So what's going to happen is now, instead of learning our doubles, instead of memorizing our doubles, what we memorize is the formula to move our beads. This really promotes number fluency. Yes, it does. Yes, it does. Because now we're going back and we're practicing our number, our how to add the 4. We can do it again with the 2. Right? We could do it again. And why? Because we have constrictions, and because now we know what our boundaries are, we can work with it. And that's what I think is the greatest thing about the abacus, is that you know that there's a constriction. So what's going to happen? The biggest question is, do I have enough beads? And it also provides, Geek and Proud, it also provides critical thinking. So when you look at it, my question is I want to add the 4. When I add the 4, do I have enough beads? Can I do it? No, I can't. Was I supposed to learn this in school? I've never seen this. No. If you learned this in school, I'd be very surprised. This is why I'm here. I'm trying to show everybody the world. I'm trying to show everybody how to use the abacus. So when we add the 2, the biggest question is, do I have enough beads? No, I don't. So how? The question is how. There's always, if there's a will, there's a way, right? How do I add 4? To add the 4, I'm going to utilize the 5. So I plus the 5 minus the 1, and my final answer is 6. Does that make sense? Yes, you're absolutely right. It really promotes number fluency. And so again, and I don't know about you guys, but I don't know this new terminology when they call procedural fluency. So, okay. So do we understand this? Now look, if you look, we have others to work with. So if we don't have enough for any of these, we have the formula to go with. So if we do, let's do 3, right? We did 4. Now we could do the same thing with the 3. When we do the same thing with the 3, let me just clean up a little bit. You'll notice it's a very similar number pattern. The pattern is very similar. So what's going to happen is we have our question, 3 plus 3. Now, remember, we have 3 plus 2 is equal to 5. And what's going to happen? They should teach this instead of the American Common Core. I'm trying to get there. I'm trying to get to mainstream math. This is why I'm using mainstream math terminology. You know, in Abacus, we don't use the word isolate the variable. We don't say substitution. We just do it. So I'm trying to be more demonstrative, right? So when we add the 3, if you notice, when I add the 3, and I want to add another 3, I'm not going to memorize. I'm not going to memorize 3 plus 3 is equal to 6, because there's no such thing as minus doubles. What I'm going to do is I'm going to understand how to utilize my formula. I have 3 and I want to equal to 5 because I want to isolate the 3. When I isolate the 3 and adding the 5 is too much, what do? I need to minus the 2. I'm sorry, did I say minus 3? I said plus the 3. So I'm trying to add the 3. I cannot add the 3. I don't have enough beads to add the 3. What do? I need to plus the 5, take away the 2. So again, this is a number pattern. This is a pattern that we've seen before. So we do plus the 5, take away the 2. So what do? I plus the 5 and I take away the 2. Notice that this is directions. I'm being as obvious as possible. I'm going to tell you how to add the 3. Plus the 5, take away the 2. Make sense? So that's what it is. And we do the same thing. We can do the same thing with the 2. But the problem with the 2 is there's not a lot of numbers with 2s that has a problem with 2. We could do 4, right? We could do 4 plus 2. So we do 4, and notice we don't have enough beads to add the 2. Well, we know how to plus the 2. How to plus the 2 is plus the 5 minus the 3. 2 and 3 are always going to be a pair no matter what. 4 and 1 will always be a pair. That's how we work. That's how it worked. But see, look, but wait, there's more. What do you mean? Well, if we know how to add, we will know how to subtract. So now what we're doing is we're building on we're compounding our math knowledge. So in minus, right, we do minus 3 minus 2 equals minus 5. That's not a thing. This is the only way I can think about it. So if I want to take away the 3, I need to minus the 5 plus the 2. Why are we doing that? Well, if you look, I have 7. And I want to minus the 3. To minus the 3, this is the number pattern. If I know how to add the 3, I know how to take away the 3. So what do? I minus the 5 plus the 2. Does that make sense? When I want to plus the 3, I go the opposite. I go plus the 5 minus the 2. If I want to I want to take away the 3, I minus the 5. The 5 is the anchor, right? The 5 is the anchor to tell me if I'm going to add a 3 or take away the 3. And that's all I'm doing. I'm only adding a 3 or I take away the 3. So what I'm doing is I'm focusing on the 5. Anybody have any questions? Did I just blow all of your minds? Welcome to the real world. You have now taken the red pill. Math is actually a lot easier. No questions. Okay. Really? Okay. So that's the thing. Like, math really is not that difficult as long as we know how to constrain. Thank you so much for the goat whispering wind. Sorry. Yeah, I'm loving the abacus. Yeah. It makes it easy and it's intuitive too. So I remember there's this one presenter. The presenter was like, "Oh, I learned how to use the lattice formula, lattice structure." It took a little bit. It was a little difficult for me to understand it, but after I got into it, it was easy. And then I'm thinking, why are we teaching children how to use the lattice if it's so difficult to use? If you have a problem as an adult to do the lattice, then I don't understand why we're teaching kids to do it. I really like how easy it is. How do you manage to blow my mind every time? Ale. All of the brain is on the wall. Is that what? Well, no, it's talking about, what is it? Talking about the red pill and the blue pill. Everybody is now in my room. You guys all have taken the red pill. You know why? Because math, adding. So we're gonna do one more step. Once we do one more step, and I will tell you the secret to all math, all adding and subtracting, and it's gonna be crazy. So what's going to happen is, what do we do? Well, what we're going to do is, okay, we've learned our 5s. We learned how to add a 5. Guess what? We know the next one. What is the next one? The biggest one that they teach school is how to make a 10. Oh, my dear Lord, that's the greatest thing. No, it's okay. It's okay. How to make a 10. We know how to make a 10. Why are we going to make a 10? Because this is where we do the next one over. So when do we get to do multiplication division? We get to do multiplication division after we understand how to do addition and subtraction and the two-step. Because the two-step, the two-step equation is what kind of baffles people. Because I do feel that that addition and subtraction is a little bit underrated. So the first thing we're going to do is understand that there's a how to make a 10. When we make a 10, we know these, right? We know these. This is easy. So again, you will notice that there's the pattern. The pattern is what? Let's do a question. Let's do this one. 4 plus 9. 4 plus 9. Well, when we do 9, right? When we do 9 plus 1 is equal to 10. This looks very familiar. What are we doing? Well, we want to isolate the 9. When we isolate the 9, boo. When we isolate the 9, right, it is 9 is equal to plus the 10 minus the 1. So what are we going to do? We're going to give me 4. I have 4. And then what's going to happen? I want to plus the 9. Remember, plus the 9 is plus the 10. So if I think about it, adding a 10 is, we know that there's 0 and our 1. So when we add the 10, we're actually adding 1 because 0 is a placeholder. So we have our 10. The 10 just means I'm going to go to the 1 column over. So I'm going to add the 10 and minus the 1. So my final answer is 13. And I should I should do that now. Does that make sense? So what did we just do? What we did is we learned how to make a 10. Easy? So we can do the same thing. Let's do 3. After we do 3, right? We do 3, and then we want to add a 9. When we add a 9, we don't have enough beads to add the 9. Again, what are we going to do? We're going to plus the 10, take away the 1. Notice, right? There's a pattern. When every time we're going to add the 9, we minus the 1. We add the 9, we plus the 10 minus the 1. This is the number pattern. So now, if you notice, if I have 12 and I want to take away 9, it's the same thing. I want to minus the 9 is minus the 10, and I add the 1. So what we just did is understand how we minus the 1 and plus the 9 and then minus the 9. Well, again, when we look, it's just the reverse of our operation, right? Minus 9 equals to minus 10 plus 1. Why are we doing that? Because when we work with 11 and I want to take away the 9, minus the 9, minus the 10 and then plus the 1. So my final answer is 2. We're all right? Good. All right. So again, we have all of these. We just did the 9, and obviously if there's a 9, there's a 1. So 1, if I want to add the 1, it's the same thing, plus the 10 minus the 9. If we do the opposite, right, if we want to take away 1, it's minus the 1 is equal to minus the 10 plus the 9. And that's how we work. Does that make sense? Okay, if that makes sense, I'm going to keep moving on because this is a very fast class. Good morning, Audrey. Good morning. Good morning. Ha. Good morning. I am everywhere. So, okay. So, how do we do? Ooh, thank you, JP. How do we do 19? So the question is 19 plus 9. It's the same thing. Oh, sorry. It's the same thing. When we look at it, we want to make sure we isolate what number we're going to do. We're going to isolate the 9. So if I do that, right, we want to isolate the 9. And I look at my column. Is there enough beads to add the 9? No, there isn't enough beads to add the 9. So what do? Then we got to go to our number. We have to plus the 10, right? Plus the 10, and then minus the 9. So what we're going to do, so our formula is add 9 is equal to plus the 10, minus 1. So what I'm going to do is I'm going to plus the 10, and I take away the 1. And there we go. So my final answer is 28. Anybody have any more questions? Because after this, we're going to go into two-step. What is a two-step? A two-step equation. I love it. Ah, thank you, Audrey. Okay, so what's going to happen is, what is a two-step? Okay, does anybody else have more questions about making a 10 and making a 5? Anybody have any questions? So what does that mean? Well, that's the secret. What's the secret? Did I just miss it? That's the secret. What we just did is we learned how to make a 5 and make a 10. Okay? We learned how to make a 5, make a 10. We learned how to take away a 10, take away a 5. That's what it is. That's the secret. The secret to all adding and subtracting are these four formulas. That's it. Okay? So this is the 10. So if we look, this is plus 1 is equal to plus the 5 minus the 4. Minus the 2 is plus the 5 minus 3. Plus 3 is plus the 5 minus 2. And then this one is plus 4 is equal to plus the 5 minus 1. Now, if you know this, you're going to know the subtraction, right? It's the same, just the opposite. So if I want to minus the 1, I have to plus the 5, right? We know this. So after we do this, then we start learning how to do the tens. After we learn how to tens, right? 4 is equal to plus the 10 minus the 6. And again, 5 plus 5, right? 5 is equal to plus the 10 minus the 5. And then if you know how to add the 10, we can minus the 10. Minus the 5 is equal to minus the 10 minus, plus the 5. You know all of this, and you know this backwards and forwards. You can solve all addition and subtraction numbers. Hands down. You cannot give me a number that I cannot work with. All of this is here. If you know this backwards and forwards, and so now what we're going to do is we're going to understand how to do it. What does it mean? This is a thing called a two-step equation, and then there's more, like, there's, majority of it is a two-step equation. What does that mean? Well, two-step equation is when we actually have to combine the two and Tetris this together. So that means that we're going to be doing some, oh yeah, this is a good one. So the first thing we're going to do is we're going to do, we know this one. Oh, I'm not going to use that. So there was a question of one of my parents. They're like, well, I want my child to know 8 plus 5 and 5 plus 8. Isn't that the same? I'm like, no, that's not the same. Why is it not the same? So when we look at it, let's do 8. So we do 8, and then we plus the 5. We want to add the 5. To add the 5, what do? We know how to add the 5. To add the 5, it is going to be plus 5 is equal to plus 10 minus 5. We know this, right? So what's going to happen, I go plus the 10, and I take away the 5. These are directions. So my final answer is 13. Okay, that's fine. That's great. Woo! We're done. Well, now the next one is what? The next one is this. 5 plus 8. So I show you 5. I'm going to add the 8. When I add the 8, what are we going to do? We know how to add the 8. We know that plus the 8 is equal to plus the 10 minus 2. We know this. So let's do it. Let's do it. So we plus the 10. Uh-oh. Ruh-roh. We can't minus the 2. So now what are we going to do? Well, we know how to minus the 2. We've learned how to minus the 2 very, very briefly, but we learned how to minus the 2. We can minus the 5. So what we're going to do is we're going to minus the 5 and we're going to add the 3, not the 2, the 3. So minus the 5 and add the 3. My final answer is 13. So our answers are the same, but remember it's the journey. The journey of how to get to the destination. We all want to be happy, but how we get there is going to be very different for everybody, right? So it's all about the process. It's all about the journey. It's not about the destination. The destination's the same. I'm hoping everybody wants to be happy, right? But it's the journey. How do we get happy? Oh, I want to have a lot of money, then I'll be happy. Oh, I want to have a good family. Oh, then I'm happy. You know what I mean? So everybody's destination, everybody's journey is always going to be different. Thank you so much for the follow, Killer James. Does that make sense? So that's why I don't want to rush to going to multiplication and division, because there's more to. I don't want to rush into multiplication and division because we got to learn about abacus life. We got to learn about the life, right? So adding and subtracting and then that's what it is. So when we talk about it, right, we could do more. We could do more two-step equations. So we have another one. So this one, are we comfortable with this one? This is kind of like, makes sense, right? So thank you so much for the hearts. Let's do another one. Let's do a little bit more complicated one. What? A complicated one? Yeah. Let's do 49 plus 5. We'll do 5 because 5 is easy. So what does that mean? Well, when we look at it, we do 49, we do 40, and we do 9. And we want to add the 5, right? We want to add the 5. In the abacus world, what we're going to do is we're going to plus the 5 is equal to plus the 10 minus 5. Now, if you look, plus the 10 minus the 5, plus the 10 is 1 and 0. We don't have enough beads. Notice here, I don't have enough beads to add the 1. What's going on? Well, if you look, now we have to use this as a two-step equation. Now this is going to be what? Plus the 1 is equal to plus the 5 minus 4. Now we're getting into critical thinking, right? We're analyzing. We have our building blocks. How do you fit them all in? Thank you so much for the likes. Wow, I'm already at 5,000. Does that make sense? It all depends on, we know our building blocks. We know we're going to either add a 10 or add a 5. How do you Tetris them all in? How do you Tetris their way through? So what we do is we add the 5 and we take away the 4. And then we don't forget to take away the 5. We're going to take away the 5. So my final answer is what? 54. 54. I do voices because I'm the only one in the room and I got to entertain myself. So, so does that make sense? So what we just did is, again, another two-step equation. Anybody have any questions? So the majority of the time will be two-step equations, right? Majority of the time? Yeah, I think so. Majority of the time it will be two-step, because as the numbers get bigger, you're going to start seeing a lot. So this, what we just learned with the adding of the 10 and adding of the 5, that is scalable. So no matter how big the number is, right? I'm just doing like, yeah, I believe that a lot of it is going to be two-step equations. Sorry, I'm just getting to class. Can you do a quick recap? Paul Diesel. Oh, hello. Hello. Welcome. Yeah, let's do a recap. So what we're going to do is we're going to learn how to read the abacus. When we learn how to read the abacus, then we can start going into adding and subtracting. So the first thing we're going to do is understand that this is 1. But then if I add the top bead, which is 5, now we have 6. So I'm going to take it away. I'm going to move it away from the horizontal bar. So what we're going to do is we're going to subtract the 5. When we subtract the 5, we're back to 1. We have 1, we're going to add 2. When we add 2, we have 2 on the abacus. 1, 2. As the 2 is touching the horizontal bar, I'm so glad I learned the math the correct way. You're making it way harder than it is. That's fine. You don't need to stay here, salon guy. You can leave and start your own life. So this is 5. This is 2. And then if I add the 5, right? This is 5. So now we have 7. We have 3, 1, 2, 3, and then add the 5. This is now 8. We have 4, 1, 2, 3, 4, and then this is 5. We have 9. Does that make sense, Paul? So what we're going to do is that now what we did is we just learned how to read the abacus. We have 1, 2, 3, 4, and then 5. After 5, we have 6, 7, 8, 9. After 9, we have 10. Wait a minute, that looks very familiar, doesn't it? That's very similar to this. So we have this and that. So if we have 10, we have 11, 12, 13, 14. After 14, we have 15. It's all the same. So when we do it, this is 9, this is 9, this is 9, and that's 9. So they're all 9s. These are all 9s. So when we look at it, we have place values. When we have place values, right? When we have place values, we have that. So we have 1s, we have 10s, we have 100s, 1000s, and 10,000. When we look at it, we have 9, we have 90, we have 900, we have 9,000, and then we have 90,000. Does that make sense? Yeah, I love the colors. Yeah. It you know what? Honestly though, just so you know, it doesn't matter what the colors are. It's just nice presentation. So here is the same thing, and it works exactly the same. So we have 1, 2, 3, 4, and then we have 5. After 5, we have 6, 7, 8, 9. After 9, we have 10. So what we're looking at is number patterns. So we have 9 and then this. The struggle is real, huh? Poor baby. Yeah, this is pure mathematics. Yeah, the struggle is very real. Salon guy. Anyways, sorry. So does that make sense? And so why is it different? The only difference is now we have more digits. This is a 7 column, and just as we have numbers, right, we have numbers of 7 columns or 13 columns. And it just matters on how big your questions are and how big the numbers are. So let's say 23 plus 4. Okay, good. So here's the question, 23 plus 14. I'm going to use this one. So this is where it gets a little bit, right? Why? Because we have restrictions, we have constrictions. This is when we start learning how to utilize the making of a 5. We're teaching children how to make a 5. So now when we make the 5, we're going to utilize this idea. We're going to utilize this concept of how to make a 5. So the question is 23. So I had 23 and I add 14. I add 1 and then I add 4. But notice I don't have enough beats to add the 4. Well, what's the point of learning this if we can't utilize it? To use this, what we're going to do is we're going to have this formula, right? It's going to be 4 is equal to 5 minus 1. What? Yeah. So why do we learn this if we can't use it? So what we did is we're using it. We're going to add the 5 and we're going to take away the 1. My final answer is 37. So my answer is 37. Does that make sense? So we have all these concepts that we're learning. We all have these concepts that we are teaching the children, but we don't utilize it too much. So what I just did here was the 5. What I did here is learning how to do the 10. And that's when you kind of came in, right? And so then that's why we have a 2-step. So thank you, Ale. Yes, we have our 2-step. So, and now because we do this, we can scale our numbers. Any other questions? Did that make sense? Thank you so much for liking the live. Wow, I can't believe it's already 7. It's like 7:30 for me. The kids act. Okay, so does that make sense? Are we okay? What's the 10 scale? The 10 scale, just kidding. The 10 scale is the same thing, right? Is understanding how to make a 10, right? A little more advanced, but let me continue to listen. Okay, yeah, not a problem. It's quick, but don't forget, I just gave you a crash course because if it was in the beginning, right, I'd be a lot slower. So, just kidding. When we're talking about the 10 scale, what we're doing is we learn how to make a 10. When we make a 10, what are we going to do? Well, let's do a question. What's going to happen is I want to add 3. So if I add the 3 on the abacus, I want to add 9, but I cannot add the 9. But wait, we know this concept. We know the concept of 10 plus 9 plus 1 is equal to 10. We know this. Well, how do we change it? Well, now we're going to do a little bit of algebra. Now this is the gateway. Abacus is the gateway to complex math. So we have this number, we have this formula, we have, not formula, we have a number sentence. 9 plus 1 is equal to 10. We have this. What we're going to do is we're going to isolate this variable. We're going to isolate the variable, excuse me, meaning that we're going to make it by itself. The reason why, because there's a 9 here. There's not enough beats to add the 9. So what are we going to do? We go 9 is equal to 10, plus the 10. But that's too much. So what do? We have to minus the 1 to make it balanced. What is it? These are directions now. Plus the 10 and then take away the 1. So my final answer is 2. So my final answer is 2. Right? Now we can scale it. So what does that mean? Well, now I can do it in other places. So if I had 2 and I add 9, what is it? It's plus the 9 is equal to plus the 10 minus the 1. So I plus the 9 is equal to plus the 10 minus 1. So I'm going to plus the 10. I added the 10, and I'm going to take away the 1. So my final answer is 11. That is, just kidding, does that make sense? Yeah. So what's going to happen is what? When we add, thank you, Ale. So now we know how to add. There's also a subtraction. Subtraction is just the opposite. So now what we're doing is we're building our concept. We're compounding our math knowledge. When we do 9, we want to do minus 9 minus 1 equals to minus 10. The reason why, now I see, we're shifting placeholders. Oh, yeah, shifting placeholders. Yes. I lost it. I lost it. Yes, I should do, oh, here it is. Yes, we're shifting placeholders. We're shifting placeholders? I don't know about that. So here, if you look, we have our ones, our tens, our hundreds, our thousands, our 10,000s. When we have it, our decimal sits between the two columns. Every column is a placeholder. Every column is a place value. So if I did this, this is 3, but then this is 30. This is 300. This is 3,000, and then we have this. We have 30,000. Like one column then shifting up accordingly. Yeah, yes. But it's the same thing, and funny, it's the same thing in how we write, but we don't see it that way, right? So if we do 9, and then we do 10, right? But how do you make it 10? How do you write 10? 10 is 2 digits. So it's interesting that Abacus mimics the way we write numbers. And some people were like, well, so here we're doing minus 9. So minus the 9 is equal to minus the 10 plus the 1. When we look at it, we have 18. We have 18, and we want to take away 9. When we take away the 9, it's minus the 10 and add the 1, which is 9. So what we're doing is we're just learning how to add and subtract. But there's more to it, right? Now, this is very simple. But the reason why we do simple, thank you, Paul, for the TikTok. Yeah. So what's going to happen is this is simple math, right? But I show you simple math because I don't want to complicate. I don't want to complicate because there's too many numbers. When we get overwhelmed with so many numbers and so many whatever. So that's why this is the fundamentals. This is the foundational. You learn. Now what we did is we just learned how to do all of this. And now you know how to add and subtract all and every question. No matter how big the question is, I can figure it out using these formulas, no matter what. And those numbers get huge. I mean, in Abacus world, it gets really big. In the mainstream world, it doesn't get so big. They only do 2 add-ins. But in Abacus world, we do like 5 add-ins, 10 add-ins, 13 add-ins. And then what are you going to do? Well, you just move the beads. So, maybe what I should do is I should show you one, okay, you know what? I'll do that. One day I will show you some questions, some big questions, but not right now. Does that make sense? Anybody have any questions? So then what we were doing when Paul was coming in, we started talking about the 2 steps, right? So the 2 steps is what? Well, we do, let's see, so we talked about this. When we do the 5, when we do 8, and then want to add the 5. To add the 5, I need to plus the 5 is equal to plus the 10 minus the 5. So when you notice, I plus the 10 and take away the 5. My final answer is 13. But then what's going to happen is when I do 5 plus 8, it's the same. No, it's not the same. Why? Because we're talking about the add-in. This add-in is always going to make or break whatever we're doing. So here, if I show you, this is 5, and I want to add the 8, I'm going to add the 8. I don't have enough beats to add the 8, so what do? I have to plus the 10 and then take away the 2. Wait, notice I cannot take away the 2. Oh, but I know, what do I know? I know how to make a 5. So this is what I do. I know how to minus a 5. So I minus the 5 and then plus the 3. My final answer is 13. So it's all about it's all about the journey, not the destination. That's where we're at. This is where we came in. And then we were talking about another 2-step. And Ale had mentioned, yes, as much as it is, a lot of the questions are 2-step. So let's take it another step. Now it's interesting because you could see it, right? You could see when the numbers move. When you see the numbers move, then Thank you. Hello, Ethan. When you see the numbers move, that's when you start to realize, how the numbers work. So what we're going to do is we're going to do, let's do like 99 plus 5. We'll do that. Why? Is it hard? It's not that hard. Because what's going to happen? You're going to see that there is a number pattern. So we do 9999, right? 999. When we do 9,999, we want to add the 5. When we add the 5, we're over here. When we add the 5, we're doing this, right? We're going to add the 5. Notice I cannot add the 5. What do we do? Well, we know to plus the 5 is equal to plus the 10 minus the 5. So we do plus the 10 minus the 5. Now, this is where commutative property happens. What does that mean? Well, we can switch this around. We can do minus the 5 and then plus the 10. So let's do that first, because I don't want to forget. I'm going to minus the 5. And then what do? I need to plus the 10. I minus the 5. I'm already done with that. Now I need to do is I need to plus the 10. Notice I cannot plus the 10. What? So this is my 1 that I need to add. I don't have enough beads to add. What do I do? Well, we know how to plus the 1. Plus the 1 is equal to plus the 10 minus 9. And again, we can switch that around. We can say minus the 9 plus the 10. We could say that. Make sense? So what's going to happen is, if you look, I'm going to minus the 9 first, and then I'm going to plus the 10. I can't. Well, then do it again. Minus the 9 plus the 10. I can't. Do it again. So I'm going to minus the 9 and then plus the 10. I can do it here. So my final answer is 10,004. So this is this is showing about the number pattern. And what we just did is we did a carrying on. We did carrying on or trading or grouping. I think that's what they call it. Grouping, trading, and carrying on. That's what it is. Oh, hey, Ayo! 0004. Regrouping. Oh, yes. Okay, yeah. Regrouping. Thank you, Marlene. Same. Yeah. Yeah, and it's interesting. So that's what I'm saying. Because you know this, now it's scalable, right? Abacus doesn't do 2 add-ins. Abacus does like 5, 10, 15 add-ins, and you just keep moving the numbers. And as you keep moving the numbers, you'll see how the numbers move. But this is simple, right? This is a simple equation. This is not what they're doing in those videos. Those videos have like 10 add-ins at a time. Or 10 lines. They do like 10 lines at a time. This is very simple in Abacus terms. The reason why, because it's only 2 lines, and they're like, that's easy. So there's this one, who is it? There's that one world record, and he did 100 add-ins. I think he did add-ins. I don't think he did takeaways. He did 100 add-ins in less than, I don't know how much. But he did a world record, and he did it through the Abacus way. Just saying. I don't know if you could do the same strategies with the other methods, but I mean, there's competitions on all of this. Like there's an Abacus competition that does this. So, anybody have any questions? If not, we can go into, can you demonstrate? Yeah, not a problem. That's a great question. Thank you so much for the question. So we do 34 minus 8. Now remember, when we minus the 8, we understand how to do it. We know that if we minus the 8, we have the opposite, right? If it's minus the 8, it's what? We know this. The friend. We're teaching this to children. So minus the 8 is minus the 10 plus the 2. That's our formula that we need to know, right? This is what I'm building off of that. So my question is 34. I want to minus the 8. So what I'm doing, I need to take away the 8 here, but I can't take away the 8. So what do? I need to minus the 10 and add the 2. We know this. Easy, right? We minus the 10 and we add the 2. How do we add the 2? How do we add the 2 to here? We know this. Adding the 2 is equal to plus the 5 minus 3. What? Plus the 5 minus the 3. My final answer is 26. 26. Oh, so does that make sense? So what is this? This is another two-step equation. Why is it a two-step? It's a two-step because of this is the one step, right? This is one step. This is the second step. But if you notice, this and this is what links the two. Thank you. Yeah, it's like I feel like it's like a puzzle. I love Abacus because I feel like it's a puzzle. You're given Tetris, right? You're given a Tetris, and you're trying to figure out how they all work. Thank you, Ethan. So the question is, The question is 100 minus 18. So the first thing we're going to do, and I like it because we actually go from left to right, just like how we read, left to right. So what we're going to do is we're going to do 100, and I'm going to take away the 1. That's the first one I'm going to do. I'm going to take away the 1. Can I take away the 1? No, I can't. What do I do? Minus the 1 is equal to what? Minus the 10 plus the 9. Why? Because I can't do the 5, right? The 5 is minus the 1 is equal to minus the 5 plus the 4. Do I have a 5 to work with? No. I don't have a 5 to work with, so I can't use it. So my question would be, my next formula is minus the 1 is equal to minus the 10 plus the 9. So I'm going to minus the 10 and plus the 9. And then I need to minus the 8. I'm over here now. Can I take away the 8? No, I cannot take away the 8. What do? Minus the 8 is equal to minus the 10 plus the 2. So I'm going to minus the 10, right? Minus the 10, and then plus the 2. Minus the 10, and then add the 2. My final answer is 82. Again, we built on this information. We continue to build and practice and understand the concepts, right? These are all basic concepts that we started in the beginning of the life. And as we go through to bigger numbers, longer numbers, they're all the same. Make sense? Right? So that's what it is. This is Abacus. Abacus shows you how the numbers work. This is what and it shows you the constraints, and then it also provides critical thinking. Because the question is always, can I do it? How do I do it? Hello, Mark. Welcome. Thank you for the follow, Cassidy. Does that make sense? So let me know if you have any questions. Thank you, Paul. So we have another question. Let's do 2, 3 minus 3. Okay. So our question is 1,000. Oh, maybe I should move my camera instead. Okay, so our question is 1,000 minus 33. Again, if you notice, I'm going to start from left to right. Left to right. That's how we read. I don't know why we don't do it that way, but this is how we read. So the first thing we're going to do is, I'm going to put it on my abacus. I have 1,000. 1, 2, 3, 4. 1,000 minus 33. So what we're going to do is we're going to take away 30, and then we take away 3. But the first thing we're going to do is we're going to understand minus 30. Minus 30. Is there enough? There's not enough. Is there enough? There's not enough. What do? We cannot minus the 5, so I'm not going to go there, right? What we're going to do is play around with the camera. Okay, so here's what we have. Minus the 3 is equal to minus the 10 plus the 7. Maybe I should just change different colors. There we go. Okay. So this is minus the 3. Again, we can change this, right? We're going to say plus the 7 is minus the 10. We're going to do this first. Why? Because I don't want to forget. So this is a concept that we can do. Right? So what we're going to do is we're going to add the 7. I'm going to add the 7, and I'm going to take away the 1. Wait a minute. I can't take away the 1. We know how to take away the 1. To take away the 1, so now what I need to do is I need to take away the 1. To take away the 1 is what? Minus the 1 is equal to minus the 10 plus the 9. Well, remember, we're going to change this. I'm sorry. I should have done plus the 9 is minus the 10. So I'm going to add the 9, and guess what? I'm going to take away the 10. Now I can take away the 10, and I'm done with that question, that part of the question. Okay? So what we did is we minus the 3. Now we're going to minus the 3 again. When we minus the 3, what are we going to do? Plus the 7 minus the 10. Plus the 7, and then minus the 10. So my final answer is 9, 6, 7. But that's a very good question. That's a good question because, again, if you notice, it's all about Tetrising the formulas that we already know. These are all the things that we know, right? I'm just practicing. Now it's just practicing and trying to get my camera to work. There's just a way of the light that I like, and it always messes up. Can you explain that one more time? Yeah, not a problem. Let's do it. Let me clean it up. Let me clean. I'm starting to see left to right. Yeah, left to right. I don't know why we do right to left. We don't read that way, so it doesn't make sense to me. I don't understand why we don't do it. Why we do it that way. So what we're going to do is the question is 1,000. So we do 1,000. 1,000 minus 33. So when we do it, we're going to 1,000 minus the 3, right? Minus 30. So the first thing we're going to do is we're going to do minus 30. So that's what this is, right? If we look, this is my ones, and I'm going to minus the 3. When I minus the 3, what is it? It's minus the 3 is equal to minus the 10 plus the 7. I'm sorry. You know what? I'm going to start off with plus the 7 minus the 10. I'm going to start with that, right? Minus the 3 is equal to plus the 7 minus the 10. Oh, look, I can plus the 7. I'm going to plus the 7. There I go. But now I need to minus the 10. Wait a minute. I can't minus the 10. How do you minus the 10? So I'm going to go back to here. If I minus the 10, right, I'm going to minus the 1. Notice the 0, the 10, 1 and 0. The 0 is a placeholder, right? So if this is 1, if I'm going to do this, right, I need to minus the 1. I'm going to take away the 1. We know minus the 1 is equal to plus the 9 minus the 10. So I'm going to do that first. Plus the 9, and I'm going to minus the 10. Oh, look, I can take away the 10. So what I'm going to do is I'm going to minus the 10. And then my question is the next one, right? Now I'm on here. I'm already done with the 3. So I'm going to minus the 3 here. To minus the 3 is what? Plus the 7 minus the 10. So I'm going to take away the 10. Focus on only two columns at a time. It doesn't matter which two columns. It's always going to be the one on the left, no matter what. It will never be on the one on the right. When you're focusing, it's always going to be the one on the left. You always want to go to the left. I just lost my cap. Yeah. Does that make sense, Ale? Oh, here he is. Yeah. So the difference is, yeah, okay, great. So the difference is yeah, in Abacus, we don't go from left to right. I mean, you could, but it just be more it just means more complicated. Why? Because you got to go through all those numbers. Right? Because if we do it the other way, you know what? Let's do the other way. Let's how advanced. How advanced are we? So 1, 2, 3, 4, right? Take away 33. So if we go the other way, if we do this first, it'd be the same thing. Plus the 7 minus the 10. Minus the 10. Oh, sorry. And then minus the 10. It'd still be the same, but we're going backwards a little bit, right? Because now there's a little bit more work. And then we take away the 3. And all I got to do is take away the 3. You could do that too. Do I do it that way? No. I think I go left to right. So, to each their own. But I think left to right, it makes more sense to me. Okay. Anybody have any questions? Whew. All right. Anybody else? Okay. So, wow. Hello, Lily. Hello, thank you for the follow. So, yeah, I mean, you could go left to right. You just got to do a lot of work in the beginning. All right. Anybody have any questions? Thank you, Paul. Thank you, Paul, for the TikTok something. Okay. Anybody have any other questions? Because if not, we're going to go into multiplication. And I don't know if, who was it? Oh, I don't know if Geek and Proud is still here. But yeah, we can go into because that's the foundation, and then because now you know that everything, all the adding and subtraction questions, these are all it. You can add and subtract any one of these with this knowledge, and that's the secret. That's the secret to everything. That's the secret to adding and subtracting. So the first thing we're going to do is understand that we're going to do multiplication now. So on the multiplication, in Abacus, we don't learn anything higher than 9 times 9. We don't remember anything higher than 9 times 9 because it doesn't make sense. It's just redundant afterwards. How is it redundant? Because I will show you. I will show you. So we can do 23. Oh, you know what? I wonder. Oh. Oh, interesting. Okay. Okay, anyways. 23 times that by 7. We'll do that. Let's do that. That's the easy one. Why is it easy? I will show you how easy it is. So the first thing on the abacus, what we're going to do is understand where are we going to put our numbers. What we do is we count our digits. 1, 2, 3. The reason why we count our digits so we know where to put our answer. So we go 1, 2, 3. So the answer is going to be somewhere around here. A ballpark figure, right? Just a ballpark. We just need to get an idea where we're going to go. So the first thing we're going to do is we're going to go outside first, right? We go left to right. So because we go left to right, we're going to do 7 times 2 equals to 14. So I add my 1. I add my 4. And then what do? 7 times 3 is equal to 21. I add 2. I add 1. Oh, wait. I can't add 2. But we know how to add 2. Plus the 2 is equal to plus the 5 minus 3. Add the 5, take away the 3. And then add the 1. So my final answer is 161. So this is the reason why I go through the go through the addition, so we can add anything. 161. Hello, Allie. Easy? Does that make sense? We're okay? We can do another one. So that is multiplication, and the multiplication's all the same. I wonder. Okay, so if we did 65 times that by 4. Yeah. Wait, the blue equals to 5. Yes, exactly, Lily. So when we're counting, right? When we're counting, we can do this. We can do 1, and then add the 5, we now have 6, right? So I'm going to take that apart. I'm going to do 2. If I do 2 and I want to add the 5, now I have 7. And then we have 3. If I add the 5, we now have 8. And we have 4. I'm going to do 4. We add the 5. Now I have 9. Does that make sense, Lily? Yeah, right, Ale? That's what I'm saying. Because on the abacus it shows, right? We just move the beads. Whereas if in school we would have to add that, right? In school we'd be like, okay, 1, 6, and then 1. But in the abacus, you can see it on it. So I know I need to add the 2. I know how to add the 2. It's plus the 5 minus the 3, and then plus the 1. So really, abacus is just moving the beads, right? And because now we know how to add and subtract, it's easy to add any number, add and subtract any number. Lily, did that make sense? So let's do another one. So again, we're going to do the same thing. We're going to go 1, 2, 3. How do I know? Yeah, okay, good. So we're going to do 1, 2, 3. We're going to do multiplication. So we're trying to figure out where we're going to put our number. So we do 1, 2, 3. This is where our number is going to sit somewhere. So the first thing we're going to do is 4 times 6 is equal to 24. We know this. We add 2, we add 4. And then what do we do? 4 times 5 is equal to 20. Again, right? We don't have enough beads to add the 2. What do? 2 is equal to plus the 5 minus 3. So I'm going to plus the 5 and take away the 3. And my final answer is 260. But again, this is different than new math. Because what do? New math, they do 4 times 60 is equal to 240. The difference is new math, they have to write it out. Abacus does it for you. It keeps track of your place values. That's the difference. So I don't have to worry about where I'm going to put my number. I don't have to worry about what number I'm using. I just need to remember or pay attention to where I'm going to put it. As long as I know where to put it, then it doesn't matter what I'm doing with all the numbers, because we're just moving the numbers as they are. It gets hairier, right, when we do more math. And, in Abacus, we do bigger questions. 90, so Paul has 90 times 9. It's the same thing. So we're going to go here, and we have our digits, right? 1, 2, 3, 1, 2, 3. 9 times 9 is 81. And that's it. Why? Because 9 times 0 is 0, so there's nothing else to do. But we don't say 90 times 9 equals to 180. We don't say that. We know our multiplication table, right? We know 9 times 9 is equal to 18. So we just keep, going through our multiplication table. We don't learn anything higher than that, right? Hello, sunshine. Welcome back. So it's a good question. I mean, it can get hairier. It can get bigger, right? So we can do bigger. If we do bigger, I think this will be the last one. Because it depends on how, it depends on if I make a mistake. So we could do 45, 7 times that by 340, 42. Let's do that. 42. Okay? Oh, sorry. There we go. 342. Let's do that. Well, I notice 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Okay, I gotta change. Why am I doing this? Well, to show the difference between new math and new math and abacus. So in new math, you do the same thing, right? You go left, left. But the problem here is in abacus, we do 4 times 3. That's easy, right? That's not a problem. In new math, what do they do? In new math, they do 400 times that by 300. I don't know about you, but that looks really crazy. That looks a little bit complicated. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So we're going to do 3 times 4 is 12. I add 1, I add 2, and I just move my finger. That's all I'm doing. So the next thing I'm going to do is, right, 5 times 3. Let's see. Oh. Excuse me, 15. I add 1, and then I add 5. 5 times 7. I'm sorry, 3 times 7 is equal to 21. I add my 2, and then I add my 1. We're done with this. What's the next one? The next one is 5. How do I know? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So I'm over here. Whoa, shit. Okay, good. I think my beads are okay. All right. 4 times 4 is equal to 16. I add 1. I add 6. Plus the 6 is plus the 10 minus the 4. Plus the 10 minus the 4. And then 4 times 5 is 20. Add 2. Add 0. 4 times 7 is 28. Add 2. Add 8. Okay, we're done with this one. We go back. I'm going to change color. 1, 2, 3, 4. 1, 2, 3, 4. 2 times 4 is 8. 8, sorry. 8 is a single digit, so I go back one column, I add the 8. Plus the 10 minus the 2. 2 times 5 is 10. I add 1, I have 0. 2 times 7 is 14. Add 1, add 4. Ugh, that's a big number. So my final answer is 156,294. I hope that's right. But that's what we do. And it's easy, right? Because you see it on the abacus, you just move the beads. Anybody have any questions? Now I really want to know if that's correct. Calculator. Let's see. 5, 4, 7 times that by... Nope. 5, 4, 5, 7 times that by 3, 4, 5. No, I'm wrong. So I did mess it up. 7. Oh my gosh. That's not right. So now I got to do it again. 12. 1, 2, 3, 4, 5, 6. No, I did that right, because that's a 2. Hold on, hold on. I typed it in wrong. 1, 2, 3. Times that by 3, 4, 2 equals. Okay, good. Thank you guys. Woo! Yeah. 342, not 345. Okay, good. So there you go. It gets a little hairy because that's the thing, right? Like the to present it is different than just working it. But then the question is if I had a problem, what would I do? If it was wrong, what would I do? I would actually start breaking it up and I would start having a running total. That's what I would do. So every time I would do this, I would have my students, have my children, just have a running total because then they can actually see what they got wrong. So that was the one thing. They would always get the multiplication wrong because it's so many numbers. Because there's so many numbers, there's a lot of adding. But because there's a lot of adding, that's when my brother, if you don't hold the abacus, my brother would come around and be like this. And I'm like, no! So he's a really mean teacher. But that's why, right? So we do this, I do this just to keep track of things. But what I would do is if this question was wrong, then I would start doing running totals. And as we start running totals, then we could see what we did wrong, what steps we were incorrect, which steps I was incorrect. Not we, but I. So, yeah. Anybody have any questions? Yeah, was that all right? Yeah, I think I'll add more bigger questions, but then that means I really have to pay attention. Or I just do the same big question and then hope that nobody remembers it. So, all right. Does anybody else have any questions? If not, I'm going to sign off. And it was really a good live. Whew. Thank you for the follow, Paul. Any other questions? I mean, we can keep going, um, but it'd be the same thing. All right. Yeah, not a problem, Paul. Thank you. No, thank you for the comments because it helps to know how to gauge and stuff, right? So we were able to go all the way to multiplication, which is not too often. Do you offer lessons? I do offer lessons. If you, I do offer private lessons. I do offer on demand as well. So I have a bunch of videos with my online. My link's in the bio. Um, Depending on how old if it's for you, then it would be private lessons. But if it's for your child, I do have online lessons. Uh, the ones I have, they talk about how to add and subtract, and then it will go into more. I just haven't built out the whole thing yet, if that makes sense. So we go into adding, subtracting, and multiplication. So these are the books. They're available on. They are available. Let me see. Where's my little? Yeah. So I have like worksheets as well. My child. Oh, she's 13 years old. Oh, okay. Then what I would do is I would start her on um if you want you can DM me and if you want to we can try private tutoring. We can talk more about that. But yeah, I do offer and if she's open to it. The biggest thing is she open to it, right? Is she open to learning a different way? Because at that age it gets a little, attitude kind of sits in and stuff. And so I wonder if she. It depends if she's open to it. If she's open to it, then it's fine, right? But if she's not open to it, then it'll be a little more difficult. Usually, the kids are not that old that joins my class. But yes, I do. If you want to, go ahead and DM me, and we can talk about it. Yeah, and then, but just so you know, we're only going to do arithmetic, right? We only do adding, subtraction, multiplication, division, right? And then we do decimals. But after that, we don't do I don't do algebra. I don't do trigonometry, calculus, or any of that. I just do arithmetic. And it's just laying the foundation of adding, subtracting, multiplication, division. So, if that makes sense, Annette. But yeah, I do sell books. And if you want your abacus, you can get it from there, or you can get it from my site. So, all right. Any other questions? Any other questions? Annette, did you know how to read the abacus before I forget? I don't know if you came in on the time to understand how to read the abacus. We can go over it if you like. Hi, Ezza. Let me know if you have any questions. Okay. But it doesn't seem like anybody has any more questions. No questions? All right. Okay. Well, I'm going to end the live. Thank you guys for joining. Thank you guys for attending. And we will see you in the next live. I'll see you in the next live. We'll see how far we can get. All right. Have a good day, everybody. Thank you guys. Thank you again for joining. Bye. Bye, Lily. Mr. Hendrick. Okay. Have a good night. Have a good day. Have a good day. Thank you, Ale. You too. Have a good day. Have a good day. And I'll see you guys in my next live. Thank you guys so much. Bye.